Welcome back. Today we're going to look at conditional probability. Your teacher should have given you a guide. If he or she didn't, what I'd like you to do, or if he or she did, pause the video, make sure you try some of these first. And then what I'll do is I'll go ahead and go over all the answers with an explanation. All right, let's take a look at some of these answers. So the story is where you have a soda A, soda B, soda C. So they did a taste test. They surveyed 200 people in each age group. So add these numbers going across. They're all going to add up to 200. And the results are shown below. The first question is, what's the probability that a participant chose soda C or was under 20 years old? So what or means, I've got to consider all the people who chose soda C as well as all the people who are under 20 years old. So I'm going to go ahead and circle that. Soda C are all of these people, and under 20 years old are all of these people. So all you have to do is add up those numbers. You can go ahead and grab a calculator, add them all up, and I believe you'll end up with 302. Now, probability means I've got to consider those who fall under this condition as well as over the total amount of people. So remember I said there were 200 people in each category. So there were 200, 400, 600, 800. So there were actually 800 people that were surveyed. So 302 chose soda C or was under 20 years old. Next question, what's the probability that soda A was chosen? So soda A, I'm going to go ahead and circle all of soda A and just add up all those numbers. If I add up all those numbers, I believe it comes out to 326 out of 800. Now part C is the conditional probability part. I'm giving you a condition. It's saying, hey, if soda A was chosen, what's the probability that the participant was 60 years old or older? So what they're saying is, hey, I only want to look at soda A. So what I'm going to do is I'm going to cover up everything else because I know something. I know soda A was chosen. So now I'm only going to look at this little modified table. So looking at this little modified table, I'm looking for people who were 60 years old or older. There are 141 of them. Now, there are not 800 total in the chart anymore because I'm only looking at soda A. Now remember from up here, I knew that this whole column equaled 326. So it's going to be out of 326 total. Because I'm only looking at soda A. All right, let's look at another question. This says 2 six-sided dice are thrown. So I'm assuming they're going to add the numbers together. It doesn't say that, but we're going to assume that that's what's going to happen. So what I typically do for these cases is I'll just make a quick little table so I can look at all the possibilities. So 2 six-sided dice, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I want to know how many different ways can I get 7 points. So I'm going to quickly do this. I could do this pretty quickly. 2, 3, 4, 5, 6, 7. And all I'm doing is adding a 4 and a 1. So there's all my possibilities if I throw in 2 dice. So this is, let's say, dice number 1, and this is dice number 2. So how many ways are there to get 7 points? Well, I just look in the table, and there's 1, 2, 3, 4, 5, 6 ways. So that's going to be 6 out of a total of all of these red numbers added together. So that's going to be a 6 by 6 grid. There are a total of 36 numbers. All right, now it's asking, oh shoot, I messed it. It just said how many ways are there to get 7 points. There are only 6 ways. So what's the probability of getting 7 points? That's what I answered up there. So it's 6 out of 36. If you wanted to, you could reduce it. I'm sure your teacher doesn't care one way or the other. You could reduce it to 1 out of 6 if you wanted to. I personally like it like that better. All right, the next part. If you got 7 points, what's the probability that the result on one of the dice was a 5? Again, this is a condition. I'm only looking at the 7 points. So I'm going to kind of hide these other numbers. So if I hide it, I'm only considering that diagonal right there. So right away I know there's 1, 2, 3, 4, 5, 6. So this is going to be over 6. Now, it's asking what's the probability that the result on one of the dice was a 5. So let's think about how I got this number here. To get a 7 here, I rolled a 6 and then a 1. To get this one, I rolled a 5 and a 2. That's one way of having a 5. To get this one, it was a 4 and a 3, 4 and a 3. This is a 2 and a 5. And this is a 1 and a 6. So now there are 2 out of 6. All right, number 3. Elizabeth and Scott are playing a game at the state fair that uses 2 spinners that are shown in the diagrams at the right. The player spins both wheels, and if the colors match, the player wins a prize. So we're going to make a probability diagram for this case. So spinner 1, I can spin a red or a blue. I'm just going to write down real quick what those probabilities are just off to the side. All right, now this is spinner number 1. Spinner number 2 is going to go up top. So I could roll a red or spin a red, blue, green, or yellow. I'm going to give myself a little bit of space here. All right. So the probability diagram means put all the probabilities in there. Now the probability of each of these are all the same. So there are 4 sections. Since they're all the same, they're all going to be 1/4. So I'm not going to stick in 1/4 everywhere. It's going to be messy and I'm going to run out of room. So, but I am going to include that here. So the probability of getting 2 reds, remember we multiply those probabilities together. So we've got 2/3 times 1/4. Go ahead and pause the video right now and fill in the rest of the table. All right, now let's take a look. Your table should look something like that. So now we want to figure out what's the probability of winning a prize. So how do you win a prize? Well, if your colors match. So let's think about where those colors match. They match here, red and red, and they match here, blue and blue. So now the probability, all I'm doing is multiplying fractions. So that's easy because I just multiplied the numerators together. So 2, I'll go ahead and write it out just so that you can see it. I'm going to take that fraction and add it to this fraction, which comes out to be 2/12. And this one comes out to be 1/12. When I add fractions, I just add the numerators and keep the denominator the same. So the probability of winning a prize is 3 out of 12. Now this is the conditional part. If you won a prize, what's the probability that the matching colors were red? So the probability I win a prize is 3 out of 12. So now I've got to figure out what's the probability of getting a red. Well, a red was this one, 2/3 times 1/4, or 2/12. And we don't like fractions within fractions, so I can just multiply the top and the bottom by 12. These cancel out, and I end up with 2/3. And that's it. All right, thanks for watching.